Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about bamboo reinforced concrete. Properties, mix proportion, design, and construction. Bamboo is characterized as a renewable, biodegradable, and energy efficiency natural resource. It is an environmentally sustainable building material. Bamboo was given recent consideration for use as reinforcement in soil. Bamboo can be used as an alternative material in reinforcement of concrete. Bamboo has been in wide usage since ancient times as a low-cost material for houses, bridges, etc. Bamboo reinforced concrete construction follows same design, mix proportions, and construction techniques as used for steel reinforced. Just steel reinforcement is replaced with bamboo reinforcement. Nature's material, bamboo has been widely used for many purposes. Mainly as a strength-bearing material. It is used for building shelters from an earlier time. Bamboo has used for scaffolding works, formwork supporting stands and many in building construction works. These are limited to medium-large projects. Bamboo is a biodegradable and renewable in nature. It is energy efficient as it is of natural origin and environmentally sustainable in nature. These properties have forced to use this in the construction field for centuries. Significance of bamboo reinforced concrete. The steel as a reinforcing material is a demand that is increasing day by day in most of the developing countries. There is situations when the production is not found enough to face the demand for steel. Hence, it is essential to have an alternative that is worth compared to steel. Bamboo is found in abundant. They are resilient and hence these can face the demand as a reinforcing material and become an ideal replacement for steel. The tensile strength property, which is the main requirement of a reinforcing material, is seen appreciable for bamboo, compared with other materials including steel. The structure of bamboo from its origin gives this property. The hollow tubular structure has high resistance against wind forces when it is in natural habitat. Working on the weak points of bamboo and bringing up an innovation of bamboo as a structural steel replacement would be a great alternative. Bamboo as reinforcement for concrete construction. The material used as a reinforcement in concrete should show all the essential properties to make the element structurally active under load. In the case of steel, we manufacture steel to the desired proportion and test for the basic strength values as a quality check. Similarly, the process must be done for bamboo too. Bamboo is found in nature, they have in different species. Each species differs in their characteristics, texture, thickness, and strength. Hence it is essential to know which species is best for reinforcing and which is not. Selection of bamboo for reinforced concrete construction. Selection of bamboo for reinforcement can be done based on these factors. Color and age. Employ bamboo having an evident brown color. This shows the age of bamboo to be at least 3 years. Diameter. Use the one with long large culms. Harvesting. Try to avoid those bamboos that are cut either during spring or summer seasons. Species. Among 1,500 species of bamboo, the best one must checked, tested to satisfy the requirement as a reinforcing material. Material properties of bamboo for reinforced concrete. Bamboo is by its origin an orthotropic material. It possesses fibers within it. It gains high strength along the fibers and low strength in the transverse direction. The bamboo has a structure of a composite material with cellulose fibers aligned across the length. It has high thick fibers near to the outer length of the bamboo, which is the main reason why they resist huge wind forces. Figure shows a schematic diagram of a bamboo sample. The node that is seen in the bamboo are represented by N. It is subjected to a lateral load P causing a maximum moment at the support. It forms a cantilever arrangement. Water absorption property of bamboo. The main requirement of bamboo when used in reinforcement is the concern for water absorption. The water absorption capacity was studied in various species, among which Dendrocalamus giganteus, known simply as DG, and Bambusa vulgaris hard, BVS, are the ones which absorbed less water. The rate of water absorption can also be reduced by certain treatment. To increase its effectiveness in impermeability, certain treatment has been carried out. The treatment substance incorporated in the bamboo material should consider 3 primary factors: the material's adhesion property towards bamboo and concrete, the formation of rough surface on the bamboo for perfect bonding, the water-repelling property of the treatment substance, bamboo strength towards bonding. As in the case of steel rebar with ribs in it, which facilitate proper bonding with the concrete, bamboo too should have proper adhesion with the concrete. The bonding strength is based on this adhesive property of cement and the compressive forces that are formed on the surface of the reinforcing bars. An untreated bamboo affects the bonding strength in the following manner. By pushing the concrete away, by the swelling of bamboo material, by the formation of voids within the concrete, by formation of cracks as the products of void formation. These problems are well faced by a proper bamboo treatment. Durability of bamboo material. Its property of being a natural product make it more exposed to environmental agents and insects. A remedy against this is to undergo bamboo curing. The curing process enables the treatment of humidity content and the starch within it, which is the main reason for insect attraction. The curing is effective only if the chosen bamboo is right one. As mentioned in the selection of bamboo, the curing of bamboo can be done either by curing on spot, immersion process, by heating. Smoke curing. The treatment must be done when the bamboo is in a dry state so that the penetration undergoes in the right way. The preservation treatment done on bamboo to take care of durability factors should have no effect on the chemical composition. The treatment itself should last, without being washed away under high water conditions if any. Durability is a major concern for bamboo material. The physical and chemical properties of bamboo are found high with low content of humidity within it. This low content would keep away molds in bamboos. Bamboo reinforcement is found more durable than steel if it has undergone proper treatments. Bamboo reinforced concrete design principles. Design of bamboo reinforced concrete is similar to design of steel reinforced concrete. The mechanical properties of bamboo reinforcement to be used for design can be assumed as per table below. Mechanical properties of bamboo reinforcement. Mechanical property. Symbol. Value, psi. Ultimate compressive strength 8,000. Allowable compressive stress S 4,000. Ultimate tensile strength 18,000. Allowable tensile stress S 4,000. Allowable bond stress U 50. Modulus of elasticity E 2.5 times 106. Procedure and equations for the design of steel reinforced concrete can be used for the design of bamboo reinforced concrete by using the mechanical properties of bamboo reinforcement in place of steel reinforcement in the calculation. Bamboo inflexural members such as beams and slabs develops some cracking under normal service loads due to its low modulus of elasticity. If such cracks in bamboo is not tolerable for structural members, then the structural design can be carried. Then steel reinforced designs or designs based on unreinforced sections are required. Bonding between concrete and bamboo as reinforcement is must for design. Split bamboo provides better bonding with concrete than whole columns when used as reinforcement. Bamboo should be split and provided in more compact reinforcement layers for better bonding with concrete. Concrete mix proportions for bamboo reinforced concrete water-cement ratio plays an important role in strength and durability of reinforced concrete. Bamboo, being a natural building material, has the property of absorbing water as discussed earlier. The absorption of water causes swelling of bamboo. Thus, concrete mix proportion for bamboo reinforced concrete must have water-cement ratio as low as possible. It should also be considered to use concrete with high early strength cement to minimize cracks caused by swelling of bamboo. The mix design of concrete can be as per the strength requirement for structure, as per structural design. Since use of reinforcement has no effect on compressive strength requirement of concrete, bamboo reinforced concrete mix proportion can be same as steel reinforced concrete mix design. Bamboo as a building material, its uses and advantages in construction works. Bamboo as a building material has high compressive strength and low weight, has been one of the most used building material as support for concrete, especially in those locations where it is found in abundance. Bamboo as a building material is used for the construction of scaffolding, bridges, and structures, houses. In many of the nations, bamboo is used to hold up suspension bridges or simply make places of dwelling. Various structural shapes of bamboo as a building material. Bamboos are treated in such a way that they assume desired shapes and structures while they grow. Squared cross-section can be obtained by compressing the growing stalk of bamboo within a square section. Arched shapes of bamboo can also be created by compressing the bamboo's growth into the desired shape. This would cost lesser than it would to get the same form with normal timber. Curved and flat shapes of bamboo are achieved through traditional techniques like applying heat and pressure. Properties of bamboo. Tensile strength. The fibers of the bamboo run axial. The outer zone are highly elastic vascular bundle, that have a high tensile strength. The tensile strength of these fibers is higher than that of steel, but it's not possible to construct connections that can transfer these tensile strengths. The common tensile stress in steel reinforcement is 160 N/mm2 and in bamboo is 370 N/mm2. The mass per volume of steel is 7,850 kg. M3 and of bamboo is about 500–600 kg. M3. Evidently bamboo will be cheaper because the price of bamboo per weight will be less than half that of steel. B. Shrinking. Bamboo shrinks more than wood when it loses water. The canes can tear apart at the nodes. Bamboo shrinks in the cross-section 10 to 16%, in the wall thickness 15 to 17%. Therefore it is necessary to take essential measures to prevent water loss when used as a building material. C. Fire resistance. The fire resistance is very good because of the high content of silicate acid. Filled up with water, it can stand a temperature of 400 degrees while the water cooks inside. Elasticity. The enormous elasticity of bamboo makes it to a very good building material for earthquake danger areas. Another advantage of bamboo is its low weight. It be transported and worked easily. The use of cranes is mostly unnecessary. Anisotropic properties. Bamboo is an anisotropic material. There are cellulose fibers in the longitudinal direction, which is strong and stiff, and in the transverse direction there is lignin, which is soft and brittle. Modulus of elasticity. The distribution of these fibers increases from the inside to the outside. The E-modulus for cellulose is 70,000 N/mm2, and about 50% of the cross-section of the fiber is cellulose. The E-modulus of the fiber is 35,000 N/mm2. In most bamboos, fibers constitute about 60% on the outside and 10% on the inside. The density of the fibers in the cross-section of a bamboo shell varies along its thickness. This presents a functionally gradient material, evolved according to the state of stress distribution in its natural environment. Durability. Bamboo with low humidity is less prone to mold attacks, especially when humidity content is less than 15%. Quality of bamboo increase with a decrease in its humidity content. Bamboo to be treated with a preservative needs to be dry to facilitate penetration. Bamboo can be dried in air, or by greenhouse process, or by oven, or by fire. The durability of bamboo depends strongly on the preservative treatment methods in accordance with basic requirements. Its chemical composition should not have any effect on the bamboo fiber, and once injected it must not be washed out by rain or humidity. Many steel and concrete structures built in the past 30 years reveal serious deterioration caused mainly by the corrosion of the steel reinforcement. Methods of working on bamboo. For a bamboo to be used as a building material, it must be worked on to create desired shape, bend and length to be used for structural or other purposes. Following are the different works involved with use of bamboo. Splitting, shaping, bending, Splitting of bamboo. The bamboo canes are split into halves or quarter sections using a knife, ideal for the job, and setting them apart by odge. About 4 or 8 segments can be acquired which are used as canes, strips or battens. Canes can be peeled to make strings and ropes up to the age of 18 months. Shaping of bamboo. Even though bamboos are naturally circular in form, but if they are grown in a box of square shape, they acquire a shape as desired. Bending of bamboo. Bamboos can be bent while they are freshly cut by heating them above the temperature of 150 degrees C. Bamboo will retain this shape even after cooling and drying off. Preservation of bamboo. A thorough treatment of bamboo is required to protect it against insects and rot before it is put into use. Commonly, a mixture of borax and boric acid are utilized for this purpose. Another procedure generally employed is to boil cut bamboo to remove the starches that draw insects. Bamboo as a building material. Utilization of bamboo for construction is achieved by a structural frame technique which is related to same approach applied in usual timber frame design and construction. In the case bamboo, floor, walls and roof are interconnected and often rely on the other for overall stability. Bamboo has played a vital role in the growth of enterprises and the rural transformation. Bamboo for foundations. There is very limited use of bamboo as foundation material because when in contact with moisture-laden surface they decay fast. However, this issue can be tackled to quite an extent through proper treatment using appropriate chemicals. The various types of foundations constructed with bamboo are: bamboo which is in direct contact with ground surface. Bamboo fixed to rock or preformed concrete footings. Composite bamboo or concrete columns. Bamboo piles. Bamboos are used in various shapes and forms to build foundation. Some of the common shapes of bamboos are: flattened bamboo shape, which is acquired by splitting freshly cut bamboo stalks and then rolling and flattening them. Bamboo mats as thin as 5 to 6 mm or 10 to 15 mm in size are woven according to design prerequisite. Phenolic resins are used in structures employing bamboo mats. Bamboo plastic composite is a pioneering technology in which bamboo fiber as raw material is blended with plastic as the core material. These mats are highly resistant to moisture and structurally more stable. Walls construction with bamboo as a building material. Bamboo is extensively used for construction of walls and partitions. Posts and beams are the main elements normally constructed with bamboo, provide structural framework for walls. they positioned in a way to be able to withstand forces of nature. An infill is used between framing elements to add strength and stability to the walls. Roofing with bamboo as a building material. Bamboo is one of the best roofing materials and provides ample sturdiness to the structure. It is a proven shield against forces of nature or animals and are considerably light-weighted, which makes them easy to install. The bamboo roofs encompass purlins, rafters, and trusses. Scaffolding with bamboo as a building material. Due to advantageous properties of bearing heavy load, bamboos are considered as one of the highly endorsed materials for scaffolding, even for tall structures. For the construction of scaffolding, cane extensions are obtained by lashing cane ends using several ropes. The ties are positioned in such a way that forces acting vertically downwards lodge the nodes in the lashing. This technique has immense significance since the joints can be realigned in the right degree. Advantages of bamboo as a building material. The various advantages of bamboo are as mentioned below. Tensile strength. Bamboo has higher tensile strength than steel because its fibers run axially. Fire resistance. Capability of bamboo to resist fire is very high and it can withstand temperature up to 4000 C. This is due to the presence of high value of silicate acid and water. Elasticity. Bamboo is widely preferred in earthquake-prone regions due to its elastic features. Weight of bamboo. Bamboos, due to their low weight, are easily displaced or installed, making it very easier for transportation and construction. Unlike other building materials like cement and asbestos, bamboo poses no danger to health. They are cost-effective and easy to use. They are especially in great demand in earthquake-prone areas. Disadvantages of bamboo. Bamboos come with their own set of drawbacks, such as they require preservation. Shrinkage. Bamboo shrinks much greater than any other type of timber, especially when it loses water. Durability. Bamboo should be sufficiently treated against insect or fungus attack before being utilized for building purposes. Jointing. Despite prevalence of various techniques of jointing, structural reliability of bamboo is questionable. Structural elements. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.